Welcome back to the Dargslan Linux series. This is part 9, and today we're tackling the piece of software that quietly runs almost everything on your machine. Systemd. Think of it as the spine of modern Linux. It boots the system, supervises every background service, and brings everything down cleanly when you shut off. By the end of this part, you'll know the handful of commands you'll use forever, and you'll even write your very first service file. Here's the path we'll take. First, what systemd actually is. That PID1 process that starts everything and keeps it alive. Then the vocabulary. Units, services, and targets. From there, we'll move into systemctl, the command you'll use daily, and learn to read its status output fluently. We'll settle the classic enable versus start confusion once and for all, and finish by writing a real service file together. 6 steps. One solid foundation. So let's start with what systemd actually is. When the Linux kernel finishes loading, it hands control to exactly one program, systemd, and that's why we call it PID1, the very first process. From there, it does 4 big jobs. It boots the machine by reading its unit files in the right order. It launches everything else you care about: networking, SSH, your web server, your database. It quietly restarts services that crash, and when you power down, it stops everything cleanly in reverse. Boot, supervise, shut down. That's the spine. To talk about systemd, we need 3 words. A unit is the umbrella term. Anything systemd manages is a unit, whether it's a background process, a timer, or a mount point. A service is the most common kind of unit, a long-running program like nginx or SSHD. And a target is just a grouping of units that describes a state the system should be in. Graphical.target if you want a desktop, multi-user.target if you just want a console. Unit, service, target. That's the vocabulary. With that vocabulary in hand, here are the 5 systemctl commands that'll carry you through almost every day on a Linux server. Start and stop do exactly what they say, but only for the current session. Restart is your go-to after editing a config file. Enable is the one people forget. It's what makes the service come back after a reboot. And status, which doesn't even need sudo, tells you if it's running, for how long, and shows the last few log lines. Learn these 5 and you're already dangerous. Since status is the command you'll run most, let's decode what it actually shows you. 3 lines really matter. Loaded tells you systemd found the unit file and parsed it without errors. Active tells you the current state. Active, running, is what you want. Failed means it's time to dig into the logs. And speaking of logs, those last few lines at the bottom are usually the fastest clue when something's gone sideways. Everything else is just extra detail. Now here's the single most confusing thing in systemd, and I want to save you hours of frustration. Start and enable sound similar, but they do completely different things. Start is like double-clicking an app. It launches the service right now, but if you reboot, it's gone. Enable is like adding something to your startup items. It tells system to launch the service on every future boot, but it doesn't actually start it today. And when you want both, which is most of the time, just chain them together with enable, now. Once you've got the hang of starting and enabling, the next question is naturally, what's actually out there? These 6 commands are how you explore. List units shows you what's running right now, and you can narrow it down to just services or just the ones that have failed, which, by the way, is always your first move when something breaks. List unit files goes broader, showing every unit installed on the system. And then isActive and isEnabled give you quick one-word answers about a specific service, which makes them perfect inside shell scripts. Now for the fun part, actually creating your own service. Drop a small text file into yexi.ata systemd system, and suddenly any script you've written becomes a fully managed service. The file has 3 sections. Unit describes it and sets ordering. Here we wait for the network to be up. Service is the heart of it. What to run, that it should restart if it crashes, and which user owns it. And install tells systemd when to start it at boot. Multi-user.target basically means a normal running system. That's it. 3 sections, a handful of lines, and you've got a real service. Let's break those sections down a little more carefully. Under unit, description is just the friendly name you'll see in status output, and after or before controls ordering relative to other units. In service, exec start needs a full absolute path. Systemd won't search your path for you. Restart decides what happens when your process dies, and user keeps things from running as root when they don't need to. And in install, wanted by hooks you into a target. Multi-user.target meaning every normal boot. Once that file is saved, 4 short commands take it from text on disk to a living service. First, daemon reload tells system to rescan its unit files and notice your new one. Then start it manually to make sure it actually runs. Check status to confirm it's active. And if something went wrong, the last few log lines right there will usually tell you exactly why. Finally, enable it so it comes back automatically after every reboot. That's the whole loop. Shifting gears a bit. If you've been around Linux for a while, you may remember run levels. Targets are their modern replacement. Named states the system can boot into or switch to on demand. Graphical gives you the full desktop, multi-user is the headless server mode, and rescue or emergency drop you into a minimal shell when things go sideways. Even rebooting is just another target under the hood. Now, before you start writing your own services, let me save you some headaches with 3 classic stumbles. First, edit a unit file and systemd won't notice until you run daemon reload. It caches everything, so make that reload reflex automatic. Second, enable just schedules the service for future boots. It doesn't start it now, so use enable now to do both in one shot. And third, never edit files under lib system, because the next package update will quietly wipe your changes. Drop your custom units in, etc., system instead. That's the safe place that overrides defaults and survives updates. And here's a quick bonus before we wrap up. Systemd has its own built-in scheduler called timers. Instead of a single cron line, you write 2 small files. A .timer unit that says when to run, and a .service unit that says what to run. The payoff is real. Timers log to the journal. They can catch up on missed runs with persistent true, and they integrate with everything else we've learned. We'll dig into timers and cron properly later in the series. For now, just know the modern option exists. So let's lock in the 5 things worth remembering from this part. Systemd is PID 1, the root of the entire process tree. Units are the nouns it manages, with services being the most common. Starting a service is not the same as enabling it. One acts now, the other survives a reboot. Your own unit files belong in etc, system, never in lib. And whenever you edit a unit, run daemon reload before restarting, or systemd will keep using the old version from cache. And that brings us to the end of part 9. Next up, we turn to logs and troubleshooting, journalctl, varlog, and dmesg, the tools that tell you what went wrong, when, and why. Now that you understand systemd, reading its journal will feel like a natural next step. I'll see you in part 10.